just want to quickly go into platform as a service, and that adds on top of the simple runtime environment pre-configured middleware stacks that are available on demand, and integrated build workflows so that you can put your code together with those middleware container images that then can run easily on the container runtime. So what does OpenShift version 3 add on top of Atomic Enterprise Platform? It really adds a self-service portal for those developers. I already showed you the web UI that a developer would see, but this is really an addition that allows for quick experimentation. I can easily set up a new project. I can easily set up a new application based on that web UI. It uses the same Kubernetes declarative concepts to define a container build pipeline. So you have things like a build configuration that tells the system how source code is to be built, how it's supposed to be spliced into a Docker base image. It also has a concept of image streams that is basically the concept of how do we declaratively manage the concept that there's currently today a version 1 of a container, and tomorrow there's a version 2 of that container. What needs to be rebuilt if that version 2 is available? What is based on that? That is everything that is contained in that image stream. OpenShift version 3 allows us to seamlessly build new containers from source code. And pretty much because it's so easy to consume new resources through OpenShift, what this does is it really helps us to enable self-sustained governance through collaboration empowerment, because once the governing body simply provides whatever it wants through means like OpenShift, the developers will take the easy route and just consume it and not go around the governance rules because it's just so easy to consume. So really now we have the developer here utilizing Red Hat OpenShift, maybe utilizing pre-built containers from the container repo to then run the scenario on the distributed container runtime. So let's look at what this could look like. In the web UI, I already created this project Java sample. So what I want to do now is I want to show you how easy it is to run a Java project which whose source code resides on GitHub. And then I will do the same thing again for a Ruby project. The point is that for the Java project, it takes a while to build. So we probably needed to run the build in the background. And the other thing is that I'm using a concept of a template here that does so many things at once that I cannot really talk to what's happening in the background. So I'm still logged into the Java sample project. And what I'm doing now is I'm saying OC process in the namespace OpenShift. That's a default namespace that comes from the OpenShift installation. And in that there's a template. It's called EAP6 basic STI. EAP6 is the JBoss Enterprise Application Platform 6. Basic means a very simple configuration, and STI is the source to image build. And that will create a number of artifacts. And if I just enter it like that, you will see a large set of configuration artifacts just piped to the command line. And you can see it's very simple JSON code that configures various different aspects. I want to use that with some small additions to it. I want to specify which URI to use. Git URI is I want to copy and paste it over from another window. https github.com/openshift/kitchensink example. The actual tag gitref is empty, and I pipe this over again to the OC command, and now I say create whatever comes from a specific file, and the file is standard in. So basically what I'm doing is I'm using this pre-configured template called EAP6 basic STI. I provide to that template a Git URI that points to a GitHub project, and then I use this created configuration to actually create those declarative goals within my Java sample project. So once I do that, I get a list of artifacts that are created. You can see there are 2 services being created. You can see there's a route created, an image stream created, build configuration created, and the deployment configuration being created. And when I look at the project, I can see now all those different artifacts. I can see my Nexus still running here. I can see that service already being created. What now also takes place is that actually a build happens. So, sorry about that. OC get builds. Okay, once it has the code, you can see that a build configuration should at least already be there. There you can see it. In a couple of seconds, a build container will trigger. And once that happens, I could even view the build logs. Just takes a while until everything is up and launched already. However, the actual build probably takes a number of minutes. So I'm not going into that. I want to look into doing the same thing for Ruby project. So I'm saying OC new project Ruby sample. And pretty much I'm doing the same thing as I did before when I launched just the very simple Nexus container. I'm starting or defining a new app, a new configuration pointing to a GitHub project, Ruby Hello World. And I can even expose the service again that was just created. OC expose service Ruby Hello World. So looking at the web UI, what has happened? Let's switch over. I'm switching over to the Ruby sample that is now available. And you can see there's this Ruby Hello World, and there's currently a build running. So let's look at what's happening there. OC get builds. I can see in the background that the source code has been retrieved from Docker. I can even view the build logs. I can follow what's going on there. I can see it's been installing the required Ruby gems. It's now running a number of Docker commands. And it's pretty much setting up a container instance which is then pushed to the container runtime, to the built-in container repository. And once that takes place, it is then pulled to the various different nodes, and there it's running. So look at that. We can see now the Ruby Hello World sample is actually running. And we can see there is one pod available. And once we click on that, you can see, welcome to an OpenShift v3 demo app. It looks like the database wasn't running. This isn't going to be much fun. Oh, so there's something that we're missing. We've created just the application, but not a database. So I can use, if I do want to create a database now, I can use the following command. Just a second. So I'm using again a template in the OpenShift namespace, which is called MySQL persistent, and I ensure that the database is actually named database. I'm using the same approach of piping it into the OC create command again to define a database configuration. And what this template does is it creates three things. It creates a service called database. It also creates a persistent volume claim called database. And that pretty much tells the OpenShift environment to use a pre-configured persistent storage that is available on an NFS share to all the various different nodes, and it creates a deployment configuration. And that persistent volume claim, OC get PVC, is bound to a specific volume. That was something that I predefined. And that basically allows the MySQL database to persist its data to a persistent storage. Now, one thing that's missing is that my OpenShift, my Ruby container does not yet know anything about the database. The actual username password to access the database is contained in the deployment descriptor of the database pod. So if I look at this deployment configuration, forgot to add --list. I can see these environment variables and do want to ensure that those environment variables, the username, the user password, and the database name, is now also part of that Ruby pod. So what I'm doing now is I'm using again this pipe trick to pipe the environment configuration from my database pod to my Ruby Hello World pod. And now the deployment configuration of the Ruby Hello World pod has been changed. And this causes, let's go here, Ruby to be deployed a second time. You can see now 2 deployments. One of them will be killed off in a second. And the other one is now the new deployment of Ruby Hello World. And now when I reload that application, it knows about the database. And I can add keys and values. So I can say put here, and I can, AVC was one of them. I could say 123 is something else, put it here. Now that information is actually persisted. So, and if I go back to AVC and hit get, I get my previous value back. So this is very nice. I can now even do the following thing. I can see what pods are running, OC get pods. And I can say, okay, that database pod, let's just kill it. OC delete this pod. OC delete, I need to specify what type of resource I want to kill. Pod, database, etc. And now what happened is the database pod was killed. However, immediately a new database pod is scheduled because the replication controller, this declarative goal, tells me that there's one additional, there's always supposed to be one database running. Now I just killed the database container. However, the state of the database was persisted in an external persistent volume. So my application shouldn't know much about that. So I can say, what was the key 123 that was entered? I get it. And it still returns that value to me because the database that was just launched just pretty much took over the persistent storage from the pod that I deleted, and all the information is still there. So you can even run stateful applications on OpenShift version 3. And as I showed you before, it's very easy to scale up, scale down, etc. So this is all very simple to use. Now moving back to our Java sample, let's see how far the Java build has gone. You can see now the Java build is also running. Just to finalize this, I can also launch the application. You can see the JBoss Kitchen Sink application is running here. And I could even now run through that application again here as well. So this concludes the platform as a service demonstration. You can see, I showed you pretty much this source to image build where an image stream container image is spliced together in a build process with code provided by a developer that is then deployed to the internal container repository where it's then pulled to the various different nodes. There's a second build process that could take just a simple Docker file and build from that and then go the same path. We offer a number of middleware services on top of OpenShift, so you can get the JBoss products as XPath middleware services and application runtime. You can get BPM, you can get our Fuse product for integration, and we will offer our Red Hat mobile application platform on OpenShift version 3 soon. Plus OpenShift version 3 also offers a number of runtime environments such as Ruby, Perl, Node, etc. out of the box. Development really benefit from it because they have a very broad selection of application components. They can really deploy applications on demand. It's so simple just to try something out on that platform because it's so easy to consume. All the build processes are automated, so you don't really have to worry about that. And it really integrates very well with continuous integration, continuous delivery tools like Jenkins, for example, so that you can get a full build pipeline, including collaboration across teams, users, and projects on OpenShift. That way, we really support very good governance, because when you have, there are two different approaches to governance. One is more process-driven. A high risk of something going wrong forces a very tight process, which then causes a low development frequency, which then causes each deployment to have a high amount of change. Whereas here we have a very high deployment frequency because it's so easy to consume, which then triggers a low amount of change for each one of those deployments, which creates a very low risk for each one of those single deployments. And all of this is based because we provide consumable building blocks instead of very restrictive processes. Okay, that concludes